All right, let's get going on today's class. So what we're going to do today is we're going to continue our look at Chapter 8, Introduction to the T-Test. So last time we introduced SPSS and we did it with the first T-Test that we learned, which was the single sample T-Test. Today we're going to continue on by taking a look at another T-Test that is used in another real-life situation. So what you'll find is that depending upon the situation that you're in, the kind of question that you're asking and the kind of experimental design that you're using, that's going to determine the T-test that you're doing. So we saw a single sample last time, and today we're going to take a look at the dependent means T-test, our next T-test in that line. But before we do that, now that we got all the exams in, we're going to do exam 2 in-class take-up. So for that, if you haven't already, I have re-uploaded all the corrected exams so you can follow along as we take this up, as we usually do. And we will be doing that right now, and we'll see how fast I finish off our look at exam number 2. Once again, a couple of things to do moving forward. First off, and I know I showed this last time, but I love to see it. Just so that everybody knows, the class as a whole is improving. All right, so like I said before, statistics is not an intuitive way of thinking. I told you that first day, but I do have a system that helps individuals learn. And I just like to point out that it is working. So I can tell people have been practicing, people have been doing their homework, because that was your the distribution of grades on exam 1. That's the distribution of grades on exam 2. And I only expect that to get better. So once again, keep doing the practice. It's working. And for those of you that are in here, which is most of you, I would say, so the mode, the most frequently achieved score this time was between 90 and 99, very closely followed by 100. So this will let you know that going forward, 100% are possible. So everybody here, there was one slip of the finger, or maybe you forgot to check that those 2 pages of which way to go on your hypothesis test. Or maybe like me, you wrote in accept and then accept again, right? Stuff happens. This is probably a slip of the wrist. So if you're in this area here, keep doing what you're doing. It's all looking great. We'll just keep on with the success. If you're over here, either there was a couple of slips of the fingers, or there was some fundamental misunderstanding about something. So if you're in here, then make sure that by the end of today, probably, hopefully even after we just took it up, you understand what it was that went wrong. So maybe you weren't accepting when you should have accepted, and you weren't rejecting when you should have rejected. Maybe you got all the way here and then decided to reject the research hypothesis and accept the null hypothesis. And as much as I do want to go a semester where that doesn't happen, I did see a couple of students who got steps 1, 2, 3, and 4 correct and had 5 the wrong way. So if that's you and you're looking at your exam now going, oh my gosh, why did I do that? Good, because you're not going to do it again. You understand what went wrong. If you're in here and you're still looking at your exam going, I still don't know what's going on, or I still can't go from a percent to a raw score to a percent, make sure you put in the time to understand that, because you're going to still need to know those things as we go further. If you're still down here, a couple of things to remember. Number 1, we need to change something. So if you need to see me, if you're still confused about what it is that needs to be done, come see me. We'll work it out. We'll figure it out. But something needs to be done, because we're still need to get you into this area over here. The other thing is that, once again, remember that your grades are on a sliding scale. So your grades for the exams are going to be graded in terms of the most points for the ones that you do great on, the least points for the ones that you do very poorly on. So we are running out of exams that are not going to be worth a lot towards your final grade. So again, don't be panicky about your final grade, but definitely something needs to be done, because I do want to take all of these and move all of them over here. So let's make sure that we're doing whatever we need to in order to make that happen for exam number 3. All right, so what we're going to do right now is we're going to continue on with a look at t-tests. We're going to take a look at the dependent means t-test, that second form of t-test. And just as a reminder, just because I don't want anybody spending money if they don't need to, you have SPSS available at home. It is through the IU Anywhere platform that we have. So if you haven't already, I highly recommend install it on your computer, get familiar with it, figure out how to use it. Sometimes just getting it set up so that Citrix receiver can communicate with your computer takes a little bit of time. So do yourself a favor, unless you want to spend all your time doing your homework here at school, make sure that you take advantage of that IU Anywhere option. All right, so what are we going to talk about today? We're going to talk about discipline and behavior change. So it used to be, back in the day, that spanking was an acceptable form of behavior modification. It used to be that parents, when they were disciplining their children and correcting their behavior, they would spank their children as a form of punishment. What psychology has shown is that that is not an effective way to change behavior. And that's why these days, oftentimes parents will use the timeout procedure, where instead of spanking, they will just have their child sit in a chair for 1 minute multiplied by whatever age there are, I think is a typical standard, in order to change their behavior. And this has been shown psychologically to be more effective than spanking in correcting behavior. Today we're going to take a look at a study that asked, well, this is effective for children. Would timeout also be effective for adults? So is it also effective for adults? We're going to take a look at a study that took a look at that to see if the same kind of behavior modification would occur if you applied this very proven juvenile strategy to a grown individual. All right, so we're going to introduce the idea of the hypothesis test with dependent means. We're going to take a look at how to do this in SPSS. And then I'll mention about your homework assignment and just any the extra practice that we have with SPSS. All right, so this is going to be another demo problem. So we'll do this live, but let's just set it up right now. So read the description. Placing children in timeout can be an effective form of punishment. Research suggests that this same technique can also be effective for adults. In the study, participants were shown a series of colored shapes and had to classify each stimulus into 1 or 2 categories. Each correct response was rewarded with a nickel, and each incorrect response was punished by a timeout period of 5 or 10 seconds. So they would do this procedure, and half of the time they would receive a 5-second timeout, and then they would redo the procedure and they would receive a 10-second timeout. During the timeout, no stimulus was presented, and the participants had no opportunity to earn more nickels. So they were literally like put into the corner. Your screen went off and you couldn't do anything. The dependent variable was the overall level of accuracy during a series of trials. Assume that each participant completed a series of trials using a 5-second timeout period. So they completed it with a 5-second timeout period, measured their accuracy, and another series using a 10-second timeout period and measured their accuracy. So half of the subjects did 5 seconds first, 10 seconds later. Half of the subjects did 10 seconds first, 5 seconds later. But you got a score for 5 seconds, and you got an accuracy for 10 seconds. Data for a sample of 9 participants is as follows. Does the data indicate a significant difference? Use a two-tailed test with an alpha of 0.05. So here are the scores. We have each participant. And the key here, the absolutely essential aspect of this test is that these subjects are measured twice. We haven't seen this up until this example here. All of our subjects have only ever been measured 1 time. This is the first time that we're measuring subjects twice. So we take participant A, we put them in the 5-second timeout condition, and we find out that they have a 71% accuracy rate. We then put them in a 10-second timeout condition, measure them again, and they have an accuracy of 86%. Participant B goes into the 5-second timeout condition, 68%. The same person goes into the 10-second timeout condition, 80%. And we do that for each and every participant. We measure them in 1 condition, and then we measure them in a 2nd condition. And the reason why this design is included with the single sample design that we looked at before. The reason that this is included with the same sort of, in the same chapter that we looked at Harlow's monkeys, is because the way that this is analyzed is to basically take a look at those difference scores, basically reduce this to one sample of difference scores. So we're going to see that in just a moment, but again, this is a little bit different than what we're used to. So in this case, what we've done is we have measured our subjects twice for the first time ever. So remember the self-esteem gym class experiment that we took a look at, where I told you we forgot to measure their self-esteem before we treated them, but then we measured their self-esteem after we treated them, and everybody was saying, well, that's a silly thing to do. You're right, it is a silly thing to do. Now we're doing it the real way, and what we do is we take a sample and we measure them before they're treated. Then we apply the treatment to them, and we measure them again. And we are asking if this new treated population belongs to, or sorry, this new treated sample, has it changed enough so it belongs to this treated population? Or did this treatment do nothing so this still belongs to that unknown, untreated population? And notice as well that that hypothesized mean is gone. So we have no idea what that hypothesized mean is. So that's the situation that we're dealing with. And this is the slide I was looking for. It's almost exactly the same situation as a single sample t-test, because what these scores basically boil down to is a single difference score. So because subject A is scored twice, we can see the difference between their accuracy in the 5-second and 10-second condition. So they have a difference of before minus after, or 5 seconds minus 10 seconds. They have a difference of minus 15%. Subject B has a difference of minus 12%. Subject C has a difference of 3%. Subject C is actually better in the 5-second timeout condition. Everybody has their scores boiled down to one score. And that one score has a mean of minus 7%, and it happens for 9 individuals in this case. All right, so we're about to see how this all shakes down, how this is all going to be done in the hypothesis testing procedure. But just so that you can see how this is almost exactly like the Harlow monkey study, that minus 7%, that's the difference that we found in our from our samples. If the null hypothesis is true, and there is no difference in accuracy between the 5-second timeout condition and the 10-second timeout condition, what would this difference be? What would we expect it to be if there was no difference in accuracy between the 5-second and the 10-second condition?
0.
It should be 0. So in essence, what this boils down to is a one sample t-test where we compare this mean to a comparison distribution that has a mean of 0. So that's why they're in the same chapter. But as we're going to see, we are actually going to let SPSS take care of all that kind of heavy lifting. So let's now get to our 5-step procedure and see how this is actually going to play out. All right, so same 5 steps as always. Let's start off with step number 1. Restate the question as a research hypothesis and a null hypothesis about the population. We want to know, is there a difference in accuracy between the 5-second and 10-second timeout periods? We're doing a two-tailed test, so we just want to know, is there a difference? Research hypothesis is that there is a difference in accuracy, and that is written out by saying that the mean accuracy for the 5-second condition is going to be different than the mean accuracy for the 10-second condition. And this is a good idea to do this as a two-tailed test in reality, because we don't know which way this is going to go. Our subject's going to be better in the 10-second condition because they're going to say to themselves, ooh, I better be more careful because every mistake I make is 10 seconds of timeout. I want to earn those nickels. I'm getting 10 seconds of timeout every single time. I better increase my accuracy. That might be the effect. Or on the other hand, they might get into that 10-second condition and say to themselves, you know what, 5 seconds of timeout was annoying enough. 10 seconds of timeout, I'm a grown individual. I don't have to put up with this. I'm going to just start doing things randomly because I'm so frustrated. Either or, right? It could go either way. This covers both situations. Maybe 10 seconds will be more accurate. Maybe 10 seconds will be less accurate. Either way, if there's an effect, it won't have the same accuracy as the 5-second condition. That's a research hypothesis. Null hypothesis is that there is no difference, that the accuracy for the 5-second condition will be the same as the accuracy for the 10-second condition, meaning that this 10-second sample is going to belong back to that original unknown, untreated 5-second population. All right, step number 2, determine the characteristics of the comparison distribution. SPSS will do this for us. Step number 3, set the cutoff sample score or critical value. We are now going to start really switching that from critical values to critical percents. We're going to start switching that from critical values to cutoff probabilities. This is going to make it incredibly straightforward and allow you to do it straight off of the SPS output. So we got to set our cutoff probability. Your cutoff probability is alpha, and it will always be alpha. So your cutoff probability is alpha, and in this case it's an alpha of 0.05. So when we're doing our steps, when we have step 2, and we need that comparison distribution, we need the mean and the standard deviation and the degrees of freedom of that comparison distribution. We will get there. When we're doing step 4, where we need that T statistic for the sample, all right, we will get there too. When we need to look at our probability, we'll find that. But right now, we're already done step 3, which is that cutoff probability. That is your alpha. And I want to make sure that everybody knows it is your alpha. And you do not touch your alpha, ever. Alpha is off limits. Alpha is set. And we're going to see that you do sometimes divide a probability by 2. But I just want to make you know that that is other probabilities. Alpha's got VIP status. It's alpha. It's first. Don't touch it. Alpha is your cutoff probability of 0.05. All right, so step 3 is done. Step 4, we got to determine our sample score on the comparison distribution. Now we're changing that from our sample score to our sample probability. So we can compare our sample's probability to our cutoff probability. And SPSS will calculate that p-value for us as well. All right, so now we're going to fire up SPSS. If you haven't already, open up the data set. You can find that one in Canvas. And also, just so that you know, screen captures of this is also in your notes. So, and it'll be on the YouTube channel as well. So I am now going to hit up IU Anywhere myself so that I can get that, because I do not have SPSS installed on this computer either. All right, so again, while I'm doing this, make sure that you're all fired up and ready to go. Make sure that you got SPSS running. You got your Excel sheet open. And we will get going.
Excel sheet from last class?
Is the Excel sheet 23. So you're looking for something that looks like that. All right, so while I'm connecting, we're starting it up. All right, so this is the data that we're going to be working with. And let's go to View, Zoom to Selection. All right, so this is the data that we're working with. And as we're going to see, we are going to have to do a couple of things with this data. The first and foremost, the biggest thing that we're going to have to do is import the data. And importantly, for importing the data, we have to decide where is this data going to go. So the first step is easy. We got the 5-second condition. We can copy that. I am hoping this is going to work because it looks like they changed SPSS on me a little bit. They did, where it is not. All right, I will be ready for this next time, SPSS. Okay, so I'm going to have to do this manually. If you are running this on the installed version, you're not going to have to do this manually. But importantly, the considerations still stay the same. I need to figure out where to put my data that I'm copying and pasting. So the first one is rather easy. We got the 5-second condition. So we put that in, and I'm going to have to do this old school manually. So we got 68, 91, 65, 73, 81, 85, 86, and 65. All right, so we have that. Yep.
I forget how to open SPSS.
So are you using IU Anywhere?
I say I downloaded it last time.
So you have to go through one IU, you have to go through IU Anywhere, and then you should be able to access SPSS. Is that? Yeah, so go to one IU. You go to IU, log in.
I thought I downloaded it.
Unless you paid a subscription, it's not going to work. So once you get in, if you don't have it in your favorites, search for SPSS, and you should be able to find it out.
Okay.
Alrighty, so we have our numbers in to this. We have our 5-second condition entered in. And let's go to variable view over here. And var 00001, horrible name for this condition. And as I mentioned before, SPSS sometimes is a little weird, sometimes gets a little bit finicky, and this is one of those instances. Because if I wanted to rename this 5-second, which seems completely reasonable, and I hit enter, it will tell me that variable contains an illegal first character. It does not allow you to name variables with a number to start it. Why? Throwback to the 90s, I guess. So anyway, we improvise. So instead of 5-second, we're going to put second 5. And notice the naming convention. Keep it 8 characters or less. So SECOND 5, 7 characters. We're safe. We hit enter. We go back to our data view, and we have our scores for our 5-second condition. This next step is one of the steps where now we have to make a decision. Now we have to decide, where does our next set of data go? So where does this 10-second data go into our SPSS data editor? And we have two choices. We can either, we have two choices, only one of them is correct. We can either put it starting here. We can start a second column and put our scores in that second column. Or we might say to ourselves, you know what, we're going to start here in the 10th row, and we're going to put it in the first column, but under the 10th row, and then we're going to identify those as the 10-second condition somehow. So those are the two options that we have. We can either put it in this position here, or we can put it in this position over here. And what's going to help you make your decision 99 times out of 100 in terms of how to format data in SPSS is to remember that each subject gets one row and only one row. So every row gets a subject, every subject gets a row, and that's it. You get the one row. So we have our first subject here has 2 scores, but subject A only gets row number 1. So any scores from subject A have to go in row number 1. And as soon as we know that, it's quite straightforward to say that accuracy of 86% has to go in column 2, row number 1. B's accuracy of 80% has to go in column 2, row 2, because B gets row number 2. That is subject B's row. And then we just fill in the rest of those following that convention. So it all goes into column 2. So 82, 89, 85, 88, and finally 76. So it all goes into that second column because, again, each subject gets the same row. So we have 2 measurements for each subject. We should have 2 numbers on each row. That's what determines that particular formatting for this data. SPSS has renamed this var 00002. So once again, we're going to go to variable view. We click on variable view right there. And we go to the variable view and say var 00002, horrible. We are going to call this second 10. And that is going to be our 10-second condition. Okay. So does everybody have this set up? Everybody's got this up? All right. So what we do now is we go to Analyze. We go to Compare Means. So remember, all of our tests are going to be found in Analyze, Compare Means. And this time, SPSS is being a little bit mean. Because remember when we were doing our single sample t-test? SPSS said, well, I don't have a single sample t-test, but I got that one sample t-test. And that makes sense to our human minds, right? Single sample, one sample, same difference. That was the correct test. This time, we're doing a dependent means t-test. But you'll notice SPSS does not have dependent means. It's got independent means, but it doesn't have dependent means listed there. So this is a case where SPSS is going to be able to do what you asked it to do, but is being a little bit unfriendly. And is being unfriendly because what we're calling a dependent means t-test, SPSS is calling a paired samples t-test. So make a note. When you're doing your dependent means t-test, it's located in SPSS under paired samples t-test. So it kind of makes sense. We got pairs of scores, but it's not the same name. So just be aware of that. We go to Analyze, Compare Means. This is our paired sample t-test. So we click on Paired Samples t-test, and we bring up our Paired Samples t-test dialog box here. And then we're almost done. We're almost set. We just need to figure out which one of these variables to put in as variable 1, which one to put in as variable 2. And I'll tell you this right off the bat. Usually I make this decision by throwing them in, doing the analysis, seeing if the analysis is in the right direction, and if not, flipping them around and redoing the analysis. So I'll show you what I mean, because it is very difficult to remember which one should go in first. So just for your own use, I highly recommend try it one way first, and then if it doesn't go the direction that you are looking for, try it the other way. So this is what I mean by that. We're going to highlight second 5. We're going to use this arrow to put it in to variable number 1. SPSS is then asking you, what's your second variable? What's variable number 2? So then we highlight second 10, and we pop that into variable number 2 over here. All right? So we got second 1 in, we got second 1 in variable number 1. We got second 5 in variable number 1. We got second 10 in variable number 2. All right? And what SPSS is going to do is it is either going to calculate your difference as variable number 2 minus variable number 1, or it is going to calculate it as the difference between variable number 1 minus variable number 2. And honestly, I cannot remember which way it is about 9 times out of 10. Unless I've been doing this yesterday, it's just usually just a buffer dump. But this takes 2 seconds to run. So rather than sitting there for 10 minutes trying to figure this out, what I would say is throw in 5 seconds as variable number 1, throw in 10 seconds as variable number 2. That's all that we need to do right now. So once you have it set up that way, you hit OK, and SPSS runs your test. Now, this is what I'm talking about right here. So SPSS ran our test. This is one of those days. All right. SPSS ran our test. And look here, we got second 5. It's told us in our paired samples t-test, we did 5 seconds minus 10 seconds. All right, we did 5 seconds minus 10 seconds. And in this case, we're doing a two-tailed test. So it's not going to be very mentally difficult. That's one of the reasons I chose this one to illustrate. It's not going to be very mentally difficult, whether we're dealing with minus 7% change or whether we're dealing with positive 7% change. Because this is telling us that people were 7% worse in the 5-second condition compared to the 10-second condition. Or they're telling us that people were 7% better in the 10-second condition. It's either way. This time, the mathematical gymnastics are not going to be so difficult to do. Sometimes they are. So for example, if they were saying, was there a decrease in the levels of depression? And you say to yourself, all right, it came out negative. So that is a negative decrease, which is a positive increase for before minus. If you have to go into that level of mental gymnastics where you're like, all right, a minus decrease equals positive increase. If that's the situation that you're in, what you want to do is go back to your data set, go back to analyze, go back to compare means, go back to paired samples t-test, go back to your already set up paired samples t-test. So it will remember you. Highlight your variables here, and you see this little double arrow button, hit that, and SPSS will switch your variables for you. So it will switch it for you, in which case you can then hit OK. And notice, if you look at the two tables of paired samples t-tests, just about all the numbers are the same, except now instead of dealing with a negative difference, I'm dealing with a positive difference. So it's exactly the same. That is telling me that the 5-second condition, the top one, is telling me that the 5-second condition is 7% worse. This one is telling me that the 10-second condition is 7% better. It's exactly the same result. So if you find that switching the variables will take you through less mental gymnastics, switch it. But definitely don't spend too much time thinking to yourself, oh, which direction is the correct direction when I'm setting it up. Throw it in one way. If you don't like the output, if it's in the wrong negative direction, pop it in the other way and reason from there. Alrighty. So that is the SPSS output. So we have completed that SPSS test. So now all that's left is to get our information from the output so we can make that final determination. So let's take a look at that. So what we want to do is we want to get to this eventually to decide whether to reject or accept the null hypothesis. So we're going to reject the null hypothesis or accept it if the t-sample score is beyond the cutoff t-score. We accept the research hypothesis and we reject the null hypothesis. Remember that we're shifting away from this procedure to not look at sample scores and cutoff t-scores, but to rather look at percentages. So it's the exact same strategy, it's the exact same reasoning, but now we're going to do it so that we can read everything off the SPSS table. If the p-value is less than your alpha value, you accept the research hypothesis, reject the null hypothesis. On the other hand, if your p-value is greater than your alpha, we accept the null hypothesis and reject the research hypothesis. Let's take a look at some of this output. Alrighty. So, first thing we do, first thing you always want to do, that top table over there, paired sample statistics, double check that top table because it will tell you whether or not you entered in your data incorrectly. So that top table is telling me that SPSS calculated a mean of 76.1% for the 5-second condition, calculated a mean of 83.1% for the 10-second condition. Go to your Excel sheet, just double check. Make sure that those means add up, means that you've done it correctly. SPSS is telling me that there are 9 scores in the 5-second condition, 9 scores in the 10-second condition. Double check. We had 9 subjects. That makes sense. And then SPSS is, well, no, that's it. So that's it for the check. And now we got to go to our comparison distribution. Remember, your comparison distribution is the distribution that would be true if the null hypothesis was correct. So we start looking for information. First thing we have is we have the standard error. there is, and this is one of the times where you have to kind of make notes of where things are in SPSS. Look up here, we got standard error of the mean. We got 2 of them. Look down here, we got standard error of the mean. We only got the 1. Make sure that you know which one you want. You want this one down here in that paired samples test output. So our comparison distribution, that is the standard deviation of our comparison distribution. We got 2.0 for our comparison distribution. The degrees of freedom for our comparison distribution, right there. We got 8 degrees of freedom for our comparison distribution. But notice that's what's missing. What's missing is the mean of our comparison distribution. Where's the mean of the comparison distribution? Well, SPSS will not report this for you. SPSS, unlike the single sample t-test, will not tell you what it used for the mean of its comparison distribution. And that is because for every single dependent means t-test, the mean of the comparison distribution is the same. Because if there is no difference between the 2 conditions, then the mean difference we can expect is 0. So if the null hypothesis is correct, the difference that we can expect, the mean of your comparison distribution is going to be 0. It's always going to be 0 for the dependent means t-test. That's why it's not reported up there, because it's just going to be redundant information. So there's all 3 of those. Mean of 0, standard deviation of 2.0 for the comparison distribution, degrees of freedom of 8. Step 3, your alpha level, your cutoff probability is 0.05. In your homework, it might ask you for your critical T, which is your cutoff score. In that case, just be aware that SPSS does not give you that information. That you're going to have to look up off of your T statistic appendix tables. So just bear that in mind when you're doing your homework. Try to use SPSS to do your homework. Not going to give you the T critical. You got to look that up. But for step 4, it will give you your sample T score. So your mean difference is right there. And very nicely, very friendly, SPSS has told you, just in case you wanted to know, I did the 5-second scores minus the 10-second scores. So it lets you know which way it was doing the difference. All right, and that's what gets switched around when I showed you that switching technique from before. So the mean difference between those 2 conditions is 7%. There was a 7% difference between the 5 and 10-second conditions. That translates into a T statistic of minus 3.5. So your sample T-score is minus 3.5. And this is another case where your textbook will sometimes say, or your homework will sometimes say, what's the difference before and after, right? What's the difference between this condition and this condition? So pay attention to the wording, because the wording will tell you if you're supposed to go before minus after, or if it's better to go before minus after. So if they ask you, what's the increase in performance after the treatment, you want to go before minus after, because increases in performance will be shown by positive differences. Again, if you run your t-test and you notice that instead of before minus after, SPSS is done after minus before, and you have to say there, you sit there and go, well, after minus before is negative, so before minus after would be positive. Even worse, after minus before is positive, so before minus after would be negative. Decreases are, if you have to do those mental gymnastics, forget it. Run your output again. Just go back, hit that switch, flip your variables, just run it again, make sure you got it in the correct direction. We're doing a two-tail test, so that doesn't matter for the two-tail. All right, so there's our T sample. That's our sample's cutoff score. We are going to use, instead of the sample cutoff score, we're going to use the probability. Probability given to you right there. And this, again, is another one where you have to make a note of where you're looking at SPSS. Because notice what they got right up here. Just waiting to trick you. Just waiting to trap you. There's this other significance. I didn't ask for this table. I can't make that table go away, but I can sure ignore it. Do not fall for that significance. We're looking for this one here, that significance two-tailed, which is 0.08. Sorry, 0.008. And now we have all of our information. So we got our significance two-tailed. We've read all our information. Now we want to know if the p-value is less than alpha, we accept the research hypothesis, reject the null hypothesis. Notice our p-value, 0.008, less than our alpha. So this is what we're going to do. We accept the research hypothesis. There is a difference between the 10-second and 5-second conditions. If it was the other case, if this was greater than the alpha, then we would accept the null hypothesis and reject the research hypothesis. So again, as it is, you compare your p-value to your alpha, and in this case, we reject the null hypothesis. We decide that we reject the null hypothesis. We decide that there is a difference between the accuracy for the 5-second and 10-second timeout periods. They're actually better accuracy in the 5-second timeout period. All right, any final questions about that? Okay, so one last thing that I'll mention before we wrap up for today. You will notice that we did 2 examples and we did 2-tailed tests both times. This is partly because a 2-tailed test is easier to kind of introduce this idea for, but also because you'll notice here that SPSS reports probabilities that are 2-tailed. So what that means is that, again, if you're going off of your sample t-score and you're going off of your looked up critical values, that will still always work. All right, that will always work. Regardless of whether you're doing 1-tailed or 2-tailed, your t-sample will be the same. Your t-critical will change depending upon whether you're doing a 1-tailed or a 2-tailed. In this case, I also want to kind of give you a foreshadowing about how this probability is handled. So what this probability says, and it's a probability 2-tailed, it says on that comparison distribution, to get a sample that goes as far as a t-score of 3.5 on one side, or as far as a sample of 3.5 on the other side, is this much of a probability, this proportion of your curve. And that proportion of your curve in total is this p-value right there. That proportion of the curve in total is 0.8%. Okay, that's what SPSS is calculating out for you. And it will always calculate out the 2-tailed test. Right? It'll always calculate out this 2-tailed probability. That is great if you're doing a 2-tailed test. However, we're going to want to do a 1-tailed test. And we're also going to want to do a 1-tailed test where we can read everything directly off of SPSS. So how do we do a 1-tailed test? It's actually massively simple. This is your p-value when you have 2 tails. What SPSS has done is it has calculated that this tail right here is 0.004. And this tail right here is 0.004. And the 2 tails together end up 0.008. That's what SPSS has done for you. It's literally saying, hey, I got these 2 proportions, these 2 tails, and it's 0.008 of the distribution. If at that point you're doing a 1-tailed test, what you tell the SPSS, you say, thank you very much. Thank you for calculating out those 2 tails. But I'm not interested in this side. I'm not interested in this tail. So let's get rid of this tail. And then you deal with what's left. And you see that we got 0.004% left. So if you're doing a 1-tailed test, all you got to do is take that p-value, you divide it by 2 to get rid of the tail that you don't want. And if this was a 1-tailed test, our p-value would be 0.4%. So that's all you need to do for a 1-tailed test. Take the p-value that SPSS is giving you and just divide it by 2 because it's giving you 2 tails. Throw one of those tails away because that's not what we're interested for. And this is why I previously mentioned, do not touch your alpha. Because P is a probability, alpha is a probability. And I have noticed that sometimes students get confused when they start dividing their alpha by 2. Not allowed. You can divide your p-score by 2. That you're allowed to do. But alpha is alpha. Alpha is special. Alpha, it's in the name. It's first. It's alpha. Do not touch your alpha. So your alpha stays the way that it does. And when you're doing a two-tail test, for example, if you're doing it in your homework, sorry, a one-tail test in your homework, and you want to do your answer via the probabilities here, take that two-tailed probability, and it tells you right there, hey, this is two-tailed. Take it, divide it by 2, get rid of one of those tails, and then proceed with your decision as you would for anything else. All right, so that is going to be it for today. We pushed it to the limit. So just a couple of reminders. Number one, keep working on those MyStatLab study plan points. Again, we are getting into some rather complicated calculations now. Feel free to use SPSS on your pre-tests. So there are plenty of resources to learn SPSS. So the more you kind of expose yourself to this before you come into the classroom, the more easily you're going to be able to pick it up. So I completely encourage you on the next chapter, when you have to do a pre-test on independent means t-tests, go to Google, SPSS, independent means t-test, watch yourself a video tutorial, use SPSS to do all the heavy lifting, get those good grades on the pre-test. And again, if you do not get 100% on the pre-test, don't forget about the MyStatLab study plan that you can complete to up your grade to that 100%. All right, we got no time today for it, but there is extra practice available in the PowerPoint, supplemental PowerPoint files, and for the rest of the Excel sheet. And also your homework assignment now, you are ready to go for part 2 of your homework assignment. Use SPSS as much as you can. You will benefit from the practice and getting familiar with it. Other than that, we are done for the day.